All right, let's jump right in. Today we're tackling a massive question, one that's been at the heart of artificial intelligence for decades. Can a machine think? And we're going to explore it through the lens of one of the most famous ideas in all of computer science, the Turing Test. You might think it's some old concept from the 50s, but trust me, it's more relevant right now than ever before.
I mean, think about it. That customer service agent you just chatted with, the person who replied to your comment on social media, how do you know you're talking to a real person? Can you be 100% sure it's not just a super smart algorithm on the other end? This isn't science fiction anymore, right? This is our daily reality. And this exact dilemma, well, it all goes back to a question someone asked over 70 years ago.
Okay, so let's talk about the imitation game. This was the brainchild of the absolute legend Alan Turing. See, back in 1950, everyone was getting bogged down in these really deep philosophical debates about what thinking even is. Consciousness, soul, all that stuff. Turing was like, let's cut through all that. He decided to ask a much simpler, more practical question. Instead of, can a machine think, he asked, can a machine act so much like a human that we can't tell the difference? That's the game, the imitation game.
And this is such a crucial point. This test isn't about being a perfect calculator. A machine could calculate pi to 1 billion digits in a second, but that doesn't make it human. No, this test is all about capturing our messiness. Can a machine tell a joke? Can it get a little sarcastic? Can it be evasive if you ask it a tricky question? Can it even, make a typo that seems believable? It's a test of being human-like, not just being correct.
So, how does this game actually work? Let's get into the rules. The setup is genius in its simplicity, but oh man, the implications are huge.
Okay, picture this. You've got 3 players, but they're all in separate rooms. Player A is the judge, the interrogator. In the other 2 rooms, you have player B, who's a real person, and player C, which is the computer program we're testing. The only way they can communicate is by typing messages back and forth. The interrogator can ask anything they want to both B and C, but they have no idea which is which. Their one and only goal? Figure out which one's the human and which one's the machine.
So when does the computer win? It's simple. It passes the test if, after a good long chat, the interrogator just can't tell them apart, or if the interrogator guesses wrong. If the machine is so convincing that a human can't reliably spot it, then boom, it's passed the Turing test. Now, you're probably wondering, has anyone actually done it? Well, sort of. Back in 2014, there was this chatbot called Eugene Guzman. It pretended to be a 13-year-old Ukrainian boy, which was a clever way to excuse any grammar mistakes or gaps in knowledge. And it actually fooled about 1/3 of the judges. But, and this is a big but, a lot of people in the AI world cried foul. They said it wasn't a true pass because it used tricks and misdirection. It wasn't really understanding, it was just a really clever puppet.
So that brings up a huge question. What would it actually take to build a machine that could pass this test for real? No tricks, no gimmicks. We're talking about building something that can genuinely hold a conversation. And believe me, it takes a lot more than just Googling answers really fast. You really need 4 key ingredients. First up, natural language processing. That's just a fancy way of saying it needs to understand our messy human language with all its slang and sarcasm and be able to talk back in a way that sounds natural. Second, it needs knowledge representation. It has to be able to store what it learns during the conversation, like a memory. Third, automated reasoning. This is the thinking part. It has to use that stored knowledge to make logical leaps and figure out answers to new questions. And finally, the big one, machine learning. It has to learn and adapt on the fly, picking up on patterns in the conversation just like we do.
Now, it's really interesting that Turing made the test text only. He did that on purpose. He wanted to strip everything else away, appearance, voice, and focus purely on the conversation. But that raises a pretty profound question, doesn't it? Can you have real, genuine intelligence if you've never actually experienced the physical world?
And that very question leads us to the next level, what some people call the total Turing test. This is where things get really wild, because we're adding a whole new dimension to the challenge. To pass this souped-up version of the test, our AI needs 2 more superpowers. First, computer vision. The judge can now show it things through a camera, so it has to be able to see and understand what it's looking at. And second, robotics. It needs a physical body, something that can move around and pick things up, so the judge can ask it to, pass me that book. Now we're talking about a whole different level of intelligence. And here's what's so incredible. You take those first 4 abilities, add vision and robotics, And you've basically just described the entire field of modern AI. How amazing is that? Turing basically laid out the roadmap for the next 70 years. But, and this is the big twist in the story, most people working in AI today, they're not actually trying to pass the Turing test. Not really.
Wait, what? So if passing the test isn't the goal anymore, then what is? What is the real quest that all these brilliant researchers are on?
This quote right here explains it perfectly. Think about how we learned to fly. For centuries, people tried to build machines that flapped their wings like birds, and they failed every single time. It wasn't until the Wright brothers stopped trying to imitate a bird and started studying the principles of flight, aerodynamics, lift, all that good stuff, that they finally succeeded. A 747 doesn't fool you into thinking it's a giant eagle, right? But it flies. It flies because we understood the underlying physics.
And that's exactly what's happened with AI. The real goal isn't just to build a perfect puppet that can imitate a human. The real prize, the holy grail, is to understand the fundamental principles of intelligence itself. How does learning work? How does our brain reason? The Turing test was incredibly important. It was like the starting pistol for the race. But it's not the finish line. By focusing on those underlying principles, we get AI that can actually do useful things, like help doctors diagnose diseases or translate languages instantly, instead of just building a chatbot that's good at fooling people.
So this all leaves us with a really important question to chew on. If just making a perfect copy of a human isn't the point, then what is? As these powerful AI systems become a bigger and bigger part of our lives, what should we be asking them to do? What goals should we set? What does success even look like for AI in the 21st century? That's a huge topic, and it's exactly what we're going to dive into in our next explainer. You're not going to want to miss it. Thanks for joining.